Nvidia Q2 earnings call. Takeaways from the call are that we are still in the midst of this massive platform shift away from general purpose compute towards accelerated compute and generative AI. This is a shift that Nvidia has been preparing for 2 decades. Maybe not specifically, particularly the generative AI is probably not something they expected, but they have the infrastructure to support all these trends. And this is definitely a massive secular shift. We at Orange Capital Partners have invested in that quite a while ago. It started with the GPU being the go-to processor for neural nets, and then it just evolved into a much broader platform where we have now networking, we have data center, we have the hardware, and we have the software. The data center is the unit of compute. These are quotes from Jensen Huang. I think for us at Orange Capital Partners, this doesn't come as a surprise. And I think the most important thing that we've discovered just recently is we're doing some research now at the university level. So we're looking at engineering platforms, for example, at the UC system in California. So what are engineering departments doing? And if you look at what they're doing, it's in a nutshell. What they're doing is they're focusing on computational methods to enhance the discovery of materials, the discovery of new technologies. And the computational methods are all driven by what we consider AI today. This is very simplified, and I don't want to put words in anybody's mouth here, but this is really what's going on. And if you then put that together with, let's say you start at the university level, you extrapolate from the university into industry, and then you have all the other stuff, which is, of course, driving, compute such as generative AI, ChatGPT, and all those things, then you can see that the demand for NVIDIA products and services is just continuing to grow at a massive scale. And that's exactly what they're showing in the numbers. So this is a nice example of a situation where we have a narrative, we have a theory, we have a situation, we have the numbers, we have the company, everybody is on the same page, and it's happening. It's happening right now. 20 years from now, we'll think back and we'll say, well, this is when it started, X started, and God knows where we're going to be in 20 years. But we think that fundamentally, we are at a massive platform shift, which means that the way we do compute is changing. Compute is the driver of progress. If you go back to the Enlightenment and you look at what happened there, it was the Principia Mathematica by Newton, which really and the differential calculus invented by Leibniz and Laplace and people like that, which then culminates in what we call engineering today. What is engineering? It's applying this math towards problems such as building bridges, building machines, thermodynamics, fluid mechanics. All of these things are applications of differential equations, which all has its roots with Newton. And that's why the Enlightenment has been such a technological boost for humanity. Now, of course, there's other things, political freedom, all that kind of stuff, but the technology, the actual technology has been computational. That's very important. It's been computational because computation is what drives progress. Computation is iteration. We've spoken about this in the past. And when we have innovations in computation, we have massive, massive potential for an increase in productivity and progress. And this is exactly what's happening right now. NVIDIA is at the forefront of this. I think the numbers are staggering. I mean, Jensen talks about $1 trillion spent in data center technology today for compute and storage and networking, and that is shifting towards accelerated compute generative AI. So we'll have some of that going over to NVIDIA, and then of course we always have, when these things happen, a massive increase in the spend anyway, because we'll have new applications that we can't even dream of, so on and so forth. So that's why this is happening. And we have continuous growth. You can argue about the stock, 20 times sales, 30 times sales. This is completely irrelevant. there's a very high likelihood that Nvidia will have 200-300 billion in sales in a couple of years, and then at 10 times that kind of clip, we're looking at 3 trillion market cap. Now it's 1 trillion. So these are the kinds of numbers. There's absolutely no reason to believe that they can't execute, because they have that beautiful combination that Tesla has, which is we have a technology and we have an entrepreneur and we have a capability that is just combining into a massive wealth generation platform. This is a Not Even Wrong podcast. It's August 23rd, 2023. This is Krim Delko. For the day, the fund is up 4%, the market's up 1%. For the year, we are up 106%, the market is up 16%, we're outperforming by 90%. So Nvidia prints the Q2 numbers. They are much higher than expected. They're guiding higher than expected. Everything is in line with the beat and raise type of narrative on Wall Street. We don't want to spend too much time with that, because this is not a Wall Street story by any means. This is a real technology story. Nvidia is putting itself into the history of humanity. It's putting itself into the history of technology, in the history of science. It is putting itself in the history of progress. Any which way you want to look at this company is at the center of what is happening right now, what's going to happen in the next, couple of decades. Why? Because they have found a way to accelerate compute at a cost that is not just lower, but massively lower than the previous compute that we had. Now, in Jensen's word, we're going from general purpose compute towards accelerated compute, and we're going towards a generative AI. What does he mean with that? General purpose compute is the CPU-driven sequential processing of instructions. If we take back of the history of compute, we have data management software. We have with the internet growing, things like Amazon and transactions, banking transactions, a lot of these kinds of things which are sequential, right? You buy something, you have to book that purchase, and then you have to book the money somewhere, and so on and so forth. Accelerated compute is not necessarily helping for that. It's helping for other things. For example, computational methods in engineering, generative AI, and so on and so forth. So what Jensen is saying is that now we have accelerated compute for a lot of workloads. We can just shift over and keep the CPU for the sequential stuff. This is what he's saying. So if you buy my products and services, you can do certain things much faster, and you also free space for the other stuff that you can still do sequentially. This is what he's saying. And why is this so important? Because accelerated compute is really happening. It's happening at 3 scales. One is the GPU, which is parallelism, massive parallelism. Then we have the networking, which is, in the case of Nvidia, something called InfiniBand, which is sort of software-defined networking type solution within the data center. So we're not talking about internet type network here. We're talking about literally how the GPUs are connected. And networking is important because it is the traffic of data, which is the main power consumption, and that is what is to be optimized in today and also in the future. So if we have a massive parallelism in GPUs, that by itself can be solved by, let's say, AMD or Intel. But what we cannot solve at a grand scale is the problem of having that data being processed at scale and then also moved back and forth at scale, and eventually also put in memory and all those kinds of things. We've spoken about this also at this podcast. And our work with Onur Mutlu has definitely enlightened us a lot in this particular perspective. So Nvidia has 3 big advantages. One is they have the hardware. The second is they have the networking. And third, they have the software CUDA, which ties everything into the ecosystem. To paraphrase Jensen also, they have the scale, they have the penetration, they have the acceptability by the developer community, which drives applications. Applications drive adoption. This is a classic platform flywheel where we have more and more adoption and more problems being solved and with more and more profit streams, so more and more adoption. So this is just a continuous, this is a continuous flywheel, for lack of better words, and Nvidia is in the midst of it. But again, I think for us, Orange Capital Partners, this ties into a lot more than just the the sales growth of Nvidia, right? We have the potential for AI, which will be only growing massively. The demand for compute, the demand for generative AI, and the demand for any kind of other machine learning driven compute is only going to increase, because we're right now still in the one-dimensional world of text. We're going in the three-dimensional world and then four-dimension, where we have video and time and those kinds of things, which will exponentially grow the data requirements, exponentially grow the power requirements, and the compute requirements, the memory requirements. So all of these things are tying together into a massive demand increase. And again, Nvidia is at the forefront of this. Now, I just want to tie this to our largest investment, which is Tesla. And for some people, this might be maybe a question mark. Well, why are you invested in Nvidia and not more invested in, if this is so central? Well, we believe that Tesla will solve the real-world AI problem. We've spoken about this in the context of Malik, excuse me if I butcher his first name, Professor Malik at Berkeley, who talks about robots being the gateway towards intelligence. I think this is where all these developments sort of tie together, right? We have robots built by Tesla, which will drive intelligence. The intelligence will drive adoption of intelligence, and then we have Nvidia providing the technology for everybody else. This is the key. The way we see it is that Tesla will solve the real-world AI problem for Tesla, which is transportation, and potentially also things along the lines of compute and material science, and basically have an integrated solution for its own necessity as far as compute is concerned, and Nvidia will do it for everybody else. Now, of course, there could be overlap, but this is the way we see it. So this is not an if or question. For those who are interested in the allocation, the way we think about this is, yes, we have a much larger position in Tesla, and this could be potentially a problem in the sense that we have too much in Tesla, maybe not enough in Nvidia. We believe that Nvidia will grow. Will it outpace Tesla? No. So we believe that the allocation will probably stay similar, maybe a little bit towards Nvidia, but that's of course, up in, it's very hard to guess these things, who will grow faster and who will do better and things like that. But the point is this, okay, we have different types of solutions for different types of problems, and both of these companies are at the forefront of providing those solutions and generating wealth while doing that. Important also, the one thing they have in common, and this is really the key takeaway here, is they are combining science, technology, scaling, and entrepreneurship into one thing, which is called a company. And this goes back to the question of exploration versus exploitation. Again, Professor Malik's quotes, and we discussed this already. We believe that exploration can happen at academia, it can happen anywhere in startups, but exploitation has to happen in companies, in large companies, very old-fashioned large companies. It's not the university, it's not the collaboration, it's not the government, it is large companies driven by entrepreneurs. And the skill that Elon Musk and Jensen Huang bring to the table, and others, but those two particularly, is that they can keep it entrepreneurial while they're scaling. The scaling is the key. Jensen's talking about how difficult it is to produce his stuff. Jensen doesn't talk enough about the manufacturing of things, which is, I would say, almost a negative, but that's okay. That's how the way he thinks. He's talking about all the components that go into their largest hardware and things along those lines. This is all fine. He's more focusing on the sort of platform, big picture stuff, which is fine. I think that's understandable. But I think the ability to scale, the ability to deliver all this demand that is, bombarding the company, that is the real source of wealth creation. So to summarize, Nvidia Q2 earnings driven by massive demand in accelerated compute and generative AI, particularly the data center business, which is growing extremely fast. Not surprising to us because we believe we are in the midst of a massive shift in compute, of a massive shift in the application of compute to problems. In fact, the problem set is changing, as we've seen in, let's say, the departments at universities where computational methods are being used, in particularly in the engineering side of things, which is not a new thing. What's new here is that the way computation is done, it's going from general purpose compute towards accelerated compute, and this is exactly where Nvidia is strong, and that's why the company is growing. Thank you.